Hey everyone, and welcome back to the channel. Today we're diving deep into one of the hottest topics in tech, the battle for AI chip supremacy. For years, one name has dominated the conversation: NVIDIA. Their GPUs have become the backbone of the AI revolution, powering everything from ChatGPT to self-driving cars. But the king's throne is looking a little less comfortable these days. A storm is brewing, and a whole army of competitors is lining up, ready to challenge NVIDIA's reign. The question is, can anyone actually dethrone the giant? Let's rewind a bit. How did NVIDIA get here? It's a fascinating story. Originally, their GPUs, or graphics processing units, were designed for gaming. They were brilliant at rendering realistic graphics by performing many simple calculations at the same time, a concept called parallel processing. It turned out this exact capability was perfect for training deep learning models, which also involve massive parallel computations. NVIDIA saw this opportunity early on. They didn't just sell hardware, they built an entire ecosystem around it. Their CUDA software platform made it incredibly easy for developers and researchers to program their GPUs for AI tasks. This brilliant move created a deep moat around their business. Switching away from NVIDIA wasn't just about buying a different chip. It meant leaving behind years of development, a massive community, and a library of optimized software. This software advantage is arguably even more important than the hardware itself. So, for a long time, if you were serious about AI, you were using NVIDIA. This dominance has sent their stock price into the stratosphere, making them one of the most valuable companies in the world. But when one company has so much power and commands such high prices for its products, it naturally creates a huge incentive for others to jump in. And that's exactly what's happening. The competition is coming from all sides, and we can break it down into a few key groups. First up, we have the old guard, NVIDIA's traditional rivals in the chip space. At the top of that list is AMD. For years, AMD has been NVIDIA's main competitor in the gaming GPU market. Now, they're aggressively targeting the AI data center. Their latest Instinct MI300X accelerator is a beast of a chip designed to go head-to-head with NVIDIA's top-of-the-line H100. On paper, it boasts more memory and memory bandwidth, which is crucial for running the gigantic large language models that are all the rage. AMD's biggest challenge isn't hardware, it's software. Their ROCm software stack is the alternative to CUDA, but it's playing a serious game of catch-up. They're pouring resources into it, trying to make it easier for developers to port their code over, but it's a long and difficult road. Then there's Intel. The longtime king of CPUs has had a tougher time cracking the AI accelerator market. Their Gaudi line of processors, acquired through a company called Habana Labs, is their main weapon. Intel is positioning Gaudi as a more open and cost-effective alternative. They're particularly emphasizing its performance per dollar and its use of standard Ethernet for networking, which can be cheaper than NVIDIA's proprietary InfiniBand technology. Major players like Naver in South Korea have adopted Gaudi, but Intel is still fighting for broader market acceptance against the well-entrenched CUDA ecosystem. But the most interesting front in this war might not be the traditional chip makers. It's the giants of cloud computing and big tech themselves. I'm talking about Google, Amazon, Microsoft, and Meta. Why are they building their own chips? Simple. Cost and control. These companies are NVIDIA's biggest customers, spending billions of dollars on their GPUs to power their cloud services and AI products. At that scale, even a small improvement in efficiency or a reduction in cost can save them billions. By designing their own custom silicon, they can tailor the chips precisely to their specific workloads. Take Google, for example. They were one of the first to go down this path with their Tensor Processing Units, or TPUs. TPUs are specifically designed for Google's TensorFlow framework and are the powerhouse behind many of their AI services, from search to photos. They're not selling these chips directly, but by using them in their own Google Cloud platform, they offer a compelling alternative to running on NVIDIA GPUs. Amazon Web Services, or AWS, the world's largest cloud provider, has its own chips called Trainium and Inferentia. As the name suggests, Trainium is optimized for training AI models, while Inferentia is for running them in production, what's called inference. By offering these custom chips as an option on AWS, they give their customers a way to potentially lower their AI compute costs. Microsoft is the latest to join this club with its Maya AI accelerator and a CPU named Cobalt. They're integrating these directly into their Azure cloud infrastructure, the same infrastructure that hosts OpenAI's ChatGPT. And not to be left out, Meta, the parent company of Facebook and Instagram, has its own custom chip family called the MTIA, or Meta Training and Inference Accelerator, designed to power its massive recommendation algorithms and future AI ambitions. This trend of in-house silicon is a direct threat to NVIDIA's business model. Every workload that runs on a Google TPU or an AWS Trainium chip is a workload that is not running on an NVIDIA GPU. It fragments the market and gives customers, especially large enterprise customers, more options and negotiating power. And it doesn't stop there. The third wave of competition comes from a vibrant and growing ecosystem of startups. Companies like Cerebras, Sambanova Systems, and Grok are all taking unique approaches to AI hardware. Cerebras, for instance, builds a single wafer-scale chip the size of a dinner plate, containing trillions of transistors designed to train massive models without the complexity of linking thousands of smaller chips. Grok is focused on lightning-fast inference speed, claiming their LPU, or language processing unit, can run large language models significantly faster than GPUs. These startups are nimble, innovative, and backed by billions in venture capital. While none of them have the scale to challenge NVIDIA on their own just yet, they are pushing the boundaries of what's possible and could become significant players or be acquired by larger ones. So, with all this competition, is NVIDIA doomed? Not so fast. Don't ever underestimate the power of an incumbent. NVIDIA has several massive advantages. As we mentioned, CUDA is their fortress. It's a mature, stable, and feature-rich platform with a massive community of developers who know it inside and out. Replicating that ecosystem will take their competitors years and billions of dollars. Secondly, NVIDIA is not standing still. They are relentless innovators. Just when you think competitors are catching up to their H100, they announce the H200 with more memory. And then they drop a bombshell, the Blackwell architecture. The new B200 GPU is an absolute monster, promising orders of magnitude performance improvements for both training and inference. They're connecting these chips with their new NVIDIA Link and quantum InfiniBand networking technology, creating supercomputers that are incredibly powerful and tightly integrated. NVIDIA isn't just selling chips. They're selling entire data center scale systems. Furthermore, NVIDIA has a multi-year head start and deep relationships with every major server manufacturer and cloud provider. They have the manufacturing scale, the supply chain, and the brand recognition that no one else can match right now. So, what does the future look like? It's unlikely that one single NVIDIA killer will emerge. Instead, we're likely heading towards a more diverse and specialized market. NVIDIA will probably remain the dominant player for high-end, general-purpose AI training for the foreseeable future, especially with Blackwell raising the bar yet again. However, AMD could carve out a strong number 2 position, especially if they can execute on their software strategy and offer a compelling price-to-performance ratio. For inference, which is the actual running of trained models and accounts for the majority of AI costs in the long run, the market is much more open. Here, in-house chips from Google, Amazon, and Microsoft, along with specialized startup solutions from companies like Grok, could capture a significant share of the pie. The market is simply getting too big for one company to own it all. Customers want choice. They want to avoid being locked into a single vendor, and they are desperately looking for ways to reduce the staggering cost of AI computation. This competition is fantastic news for everyone. It will drive innovation faster, it will push prices down, and it will ultimately make AI more accessible to more people and companies. The AI chip war is just getting started, and it's going to be one of the most exciting and important technology battles of the coming decade. NVIDIA is still the undisputed king, but they're now fighting a war on multiple fronts against a growing alliance of powerful enemies. They have the crown, but uneasy lies the head that wears it. What do you think? Can anyone truly challenge NVIDIA's dominance, or is their moat just too wide and deep to cross? Let me know your thoughts down in the comments. Thanks so much for watching, and if you enjoyed this deep dive, don't forget to like, subscribe, and hit that bell so you don't miss our next video. See you next time.